Hi students, in this video I am discussing the doubts given by you all on alcohols, phenols and ethers. There are around 8 questions which we are discussing, and with that we will complete all the doubt solving from your NEET book. Let us begin. Phenol is treated with, here it is NaNO2 and sulfuric acid, NaNO2 and sulfuric acid gives us B, and this with water gives us C, and C on reaction in alkaline medium is giving us D. Let us see what this reaction is indicating. When we take phenol, and we treat it with NaNO2, sodium nitrite. This is the structure of NaNO2 in presence of sulfuric acid, which is a little concentrated. Then phenol undergoes electrophilic substitution. As you all know, during electrophilic substitution, one of the H plus from benzene will get replaced by another electrophile, and here in this reaction, the electrophile will be NO plus. Now students, as we all know, dash OH is an electron releasing group, and an electron releasing group will initiate or will complete the electrophilic substitution reaction on ortho and para position of benzene, where the para product will be the major product, except in case of certain compounds like nitrophenols, where due to hydrogen bonding the ortho product is more stable. So phenol undergoes electrophilic substitution at para position, and here at that para position you can see what gets attached is the nitroso group, and we get para nitroso phenol. That is the product obtained, para nitroso phenol. Now this para nitroso phenol again reacts with a molecule of phenol in presence of H2SO4, and what we get is, just see, this is the phenol, this is another benzene ring which gets attached here. That is, you can see the N double bond O, you can see the N double bond O, that region, this gets attached to the benzene. Don't get confused. 1, 2, 3. So pi bond will not come here, but the pi bond shift to opposite sides like this, because carbon is tetravalent. We all know that. And then double bond this OH. Since oxygen is divalent, but here you see oxygen is divalent, so oxygen should make 2 bonds, but here you see oxygen is making 3 bonds by using one of its lone pair. So we put a positive charge on the copodia of oxygen, and then this gets connected to HS O4 minus. Now let us name it. This molecule is a indophenol derivative. We call it phenol, indophenol, hydrogen sulfate. You can write the name also, but I'm not writing the name. You understood it. So phenol, indophenol, hydrogen sulfate. Remember, this is deep blue in color. Deep blue color. Now see the question. Question is indicating that it should react with NaOH. But what happens is, before that we are adding a molecule of water. So my dear students, when we add water to it, it gets hydrolyzed and the byproduct is sulfuric acid, H2SO4 is out, and you can understand it very clearly. If we remove sulfuric from this, from here if I remove sulfuric, this, obviously, then the product is correct. This is the product. This is phenol, indophenol. No hydrogen sulfate. This is phenol, indophenol. And it is red in color. Now the last step says add a NaOH. So when I treat it with NaOH, you know phenol is acidic in nature, so this H plus is acidic. So this goes with this OH and water is eliminated. And what we get is O minus, because I removed a proton from there. And children, what we get is like this, correct? This negative, why did I write? I hope it is clear to everyone, correct? And opposite bonds and double bond, O, and if you take care, here Na is left, which is Na plus. Now this what I wrote is sodium salt of phenol, indophenol, and this is also blue. So the color changes from blue to red to blue. This is Lieberman's nitroso reaction. This is Lieberman's nitroso test, which is used to detect phenol. The change in color from blue to red to blue can be given only by phenols. So it is one of the detection tests to check whether the given organic compound to you in the laboratory is phenol or no. Also, we can use this, to distinguish phenol from other organic compounds. Okay, question number 2. An organic compound having a CH and a O has a pleasant odor with boiling 78 degrees centigrade. I know the boiling point, and so I know the molecule. 78 degrees centigrade is the boiling point of ethyl alcohol, that is ethanol. So maybe this answer is ethanol. No, just wait. Let's check first. An organic compound having CHO has a pleasant odor, boiling point 78 degree, maybe ethanol. Okay, let me check. On boiling A with concentrated H2SO4, it gives a colorless gas. Yeah, this is another hint. See students, if I take ethanol and I treat it with concentrated sulfuric acid, then you all know it will undergo intramolecular dehydration, and I'll be getting ethene. And my dear children, ethene has pi bonds, and pi bond will definitely decolorize bromine water and alkaline KMNO4. So the answer is ethanol. I hope the question is clear to you, because if the compound contains CHNO, pleasant odor, and the main hint is 78 degrees centigrade boiling point, which is the boiling point of ethyl alcohol, तो 50% तो सॉल्व हो गया यहाँ पर. अब वो बोलता है इस कंपाउंड में अगर कॉन्सेंट्रेटेड सल्फ्यूरिक डाला तो एक ऐसा गैस देगा जो ब्रोमीन वाटर को डिकलराइज करता है. वी ऑल नो ब्रोमीन वाटर गेट्स डिकलराइज्ड विद पाई बॉन्ड्स विद अनसैचुरेशन, एंड इथेनॉल ऑन डिहाइड्रेशन विल गिव ethene, and ethene is gaseous, and ethene decolorizes bromine water and alkaline KMNO4. We've learned it in 11th standard. Alkaline KMNO4 with ethene, neutral aqueous medium, will undergo hydroxylation, and the purple color of KMNO4 will be vanished and will become colorless. Okay, yeah, this one. An oxygen containing compound, okay, has 52% carbon. Okay, I get carbon 52%, and we have hydrogen 13%. So carbon है, hydrogen है, बाकी का oxygen है. So just see 52 plus 13, 100 में से minus कर दो. So 35% oxygen. Now carbon atomic weight is 12. Hydrogen is 1 and oxygen is 16. So we find the atomic ratio, that is 52 by 12 and 13 upon 1 and 35 upon 16. Just try. What are you getting? What is the answer you are getting? Hmm? 52 upon 12, 13 upon 1, 13 upon 1. चलिए हम आपको बता देंगे, बाकी तो सॉल्व करिए. This will be 4.33, this will be 13, this will be 2.18. Now you have to divide each one by the smallest ratio. मतलब सबको इससे डिवाइड करना है, ठीक है? So 4.33 divided by 2.18, 13 divided by 2.18, and 2.18 divided by 2.18. So 2.18 divided by 2.18 will be 1. And what about the other two? 4.33 upon 2.18 is 1.9, and this is 5.9. So round it off to the nearest whole number, 2. This is 6, and this is 1. So the compound is C2H6O. Let us check, are we right? Vapor density is 23. So molecular weight we know is 2 into vapor density. So 2 into 23 will be 46. Okay. Is this 46? Let us check C2. So 12 to 24, 24 plus 6, 30, 30 and 16. Yes, it is 46. Okay. So ये C2H6O correct है. Liberates hydrogen with Na. Now, this formula can be of ethanol and dimethyl ether. Correct? It is the formula of ethanol and dimethyl ether. Now, children, ether doesn't react with Na. Ethanol reacts with Na. So, it liberates hydrogen with Na. Okay, so ethanol liberates hydrogen with Na. पर ध्यान से क्वेश्चन पढ़ो, उसने ये नहीं पूछा कि ये कंपाउंड क्या है, उसने पूछा है इस कंपाउंड का आइसोमर क्या है. तो इथेनॉल का आइसोमर है डाइमिथाइल ईथर, so answer is dimethyl ether. So that is why in the option they have given dimethyl ether, ethanol, both. But you should be smart, very very smart. The answer is dimethyl ether, because of course हाइड्रोजन विल बी लिबरेटेड फ्रॉम इथेनॉल, पर वो पूछ ही नहीं रहा इथेनॉल, वो बोलता है इस कंपाउंड का जो आपने निकाला उसका आइसोमर कौन है, तो उसका फंक्शनल आइसोमर ईथर है. Ethers are functional isomers of monohydric alcohols. Okay, okay, the next question now. It is SN1 mechanism. We've solved many questions on SN1 mechanism. Yet another we will see. The hydrolysis of 2-bromo-3-methyl butane. So I am making 2-pe-bromo, okay, 3-pe-methyl and butane. Hydrolysis, okay, meaning aqueous NaOH, and obviously it is saying SN1. So SN1 is initiated by formation of a carbocation. अगर आपको याद है तो KUCH. Okay, so the moment that is removed, a carbocation is formed, CH3 and a CH3 here. Now, this is a 2-degree carbocation, children, which will immediately undergo shift. This can go here and this H can come here, which is called 1,2 hydride shift. 1,2 hydride shift, and we will be getting, see what will happen, this C, H comes here 2, एक ऊपर छतरी, एक बाजू में छतरी और प्लस इधर आ गया. So the 2-degree carbocation gets converted to more stable 3-degree carbocation by 1,2 hydride shift. And now the story is over. This will now react with OH minus and you will be getting. We have solved such a question in our notes. Alcohol, phenol, ether, APE, 94, 95, 96, 97, 98. All these kinds of reactions and mechanisms are given. So please read. I'm not saying you should not ask me doubt. Go on asking me doubt. But my dear, read. Reading is very, very important. So see, a 2-degree alkyl halide gave a 3-degree alcohol because in between the carbocation undergoes 1,2 hydride shift to get to convert the 2-degree carbocation to a 3-degree more stable carbocation, and hence the final product is a 3-degree alcohol. Now we come to question number 5. Very simple if you see. Why? Because I'll tell you, see, it says A gives dialkyl ether. Now, among the methods of preparation of ethers, the best method to prepare simple ethers is Williamson's continuous etherification. अब अगर आप देखें यहाँ reagent दिया है concentrated H2SO4 and temperature is 413 Kelvin, which is the reagent and temperature of continuous etherification process, and continuous etherification is given by primary alcohols best because it is a SN2 mechanism. तो ये 4 ऑप्शन में एक ही प्राइमरी अल्कोहल है, आपके बुक्स में देखिए, and that is pentan 1-all. बाकी सब secondary tertiary alcohols दिए हैं, so they are not the answers. Okay? Which one can be distinguished using sodium hypoiodide? We will just complete the question. Wait a minute. Which can be distinguished? Okay, पहला दिया है ethanol and acetone. Okay, first option is CH3CHO and CH3COCH3. Fine. Next is propanol and acetone. Okay, so next is CH3CH2CHO and CH3COCH3, which can be distinguished. Okay. Next is ethanol and butanol, and then methanol and propanol. Okay. So ethanol and butanol, that is like this. And the last is methanol and propanol. Okay, these are the options, my dear students. Now, the very first thing you should know is this is iodoform test. Iodoform test I have given you in halogen derivatives of alkanes, उतना पहले करा दिया, which is H84. My notes, halogen derivatives of alkane, page number 84. You can see there, sodium hypodiode is used to detect the methyl keto group. It is given by all the compounds having the methyl keto or the acetyl group. Now, if you see acetaldehyde has methyl keto, this has methyl keto, so we can distinguish them. No, so we cannot distinguish them because इसमें भी methyl keto है, इसमें भी है, दोनों में है, तो we cannot distinguish. Propanol में methyl keto नहीं है, इसमें है, so we can distinguish. इसमें मिथाइल कीटो है और इसमें भी देखो सेकंड पे छतरी CO बन जाएगा, तो we cannot distinguish it. ये दोनों में मिथाइल कीटो नहीं है, so we cannot distinguish. So answer is B. Okay. Picrates are formed by. Next question is picrates are formed by. Again, this question should not come in doubts. You know why? You must be thinking, oh ma'am, you're telling this should not come, that should not come. Yes, my dear, because in my notes, I have discussed this on page number APE 107. That is alcohols, phenols, ethers, our notes 107. Specifically, मैंने दिया है ये रिएक्शन आपको कि पिक्रेट्स किस तरह से बनाए जाते हैं. तो वहां पे एक बड़ा अच्छा मेथड दिया है. एक मेथड तो आपको पता है पिक्रेट बनाने का. फिनॉल is treated with concentrated nitric and sulfuric. तो आपको पिक्रिक एसिड मिल जाता है like this. बट अगर आप देखेंगे AP 107, so you will understand I have given there that nowadays in industry, picrates, that is picric acid, is not prepared like this directly, but first phenol is converted to sulfonic acid derivative of phenol, that is it is converted to hydroxysulfonates or hydroxysulfonic acid, और उस मिक्सचर को फिर नाइट्रेट किया जाता है, which prevents further oxidation of the phenolic OH group and gives more yield. Read it. This one. An alcohol on treatment with alkaline KMnO4 gives brown PPT. अब देखो, alkaline KMnO4 is the oxidizing agent, correct? Oxidizing agent में क्या क्या है? Acidic K2Cr2O7, alkaline KMnO4, dilute nitric acid, chromic acid, and things like that. Now, oxidation of an alcohol is a phenomenon or is a reaction of its alpha hydrogen. Now, a primary alcohol has 2 alpha hydrogen, a secondary alcohol has only 1 alpha hydrogen, while a tertiary alcohol does not contain any alpha hydrogen. So, it is very clear that if oxidation is of alpha hydrogen and tertiary alcohol does not contain any alpha hydrogen, then tertiary alcohol will never react with oxidizing agent like acidic K2Cr2O7 or alkaline KMnO4 or dilute nitric or chromic acid or whatever. And hence this answer is either a primary or a secondary alcohol. And now if you see, this one is tertiary, this one is tertiary, this one is tertiary, this one is primary. So that's the answer. So children, with this I completed all the doubts that you posted me for alcohol phenol ether, your NEET book. And this is our lecture, Kuch Khas Hai. That is lecture of Kuch Khas Hai. All your doubts. So, bye-bye. Take care. Love and blessings to all of you there.